Hello and welcome everyone. This is Benam from Banks and Markets, and in this video today I want to talk about bond volatility measures, namely duration, modified duration and convexity. Basically I am going to provide you a numerical illustration where I will be using the formula for duration, which is this one, the formula for modified duration, which is here, and I will also be explaining you how you can make your life easy with the help of MS Excel built functions related to duration and modified duration, which are simply equal to duration and equal to m duration. Last but not least, what I will do, I will also help you understand why we need to combine convexity measure and modified duration measure when we need to find out the price volatility for a bond when the change in yield is higher. Okay, so that's on the agenda today. So let us begin. So here I've got an example to show you, and in this example you can see that I have found the price of the bond using the price equal this function available through Excel. So this is price of the bond for a bond which has following characteristics, i.e. the bond has a maturity of 25 years, so therefore we've got 50 period, the bond has such coupon, yield rate, coupon payment frequency, and so on. Those of you who are not familiar with this bond price computation, please see my previous video wherein I have provided 4 different methods of finding the price of a bond. So this example is basically exactly similar to the one in my previous video, these numbers, but what I can do just to give you some change is, instead of finding the price of a bond for premium, i.e. bond is selling at premium here, I can make it a case where bond is selling at discount, and the only thing I need to do is simply flip this. Okay, change coupon rate from 9% to 6 and yield 6 to 9. So I'm going to do that, 6, 9, and now I can see the price of the bond is $70.36. So this is what I want to find out using the formula approach related to price of a bond that we learned in my previous video. So let me do that. So now I just need to discount it by the yield, which is this 3%. I am going to lock it now, and then power time, which is this period. So I have computed present value of my cash flows. I'm double clicking so that it has computed all present values for all 50 periods, including for the maturity value, which is $100 here as an example. So we know that this is now coming 138.5. now hang on, remember I changed the 6% and 9% here, but didn't change the same here, so I just need to make those changes here as well. So you will now see that this and this amount, they are exactly same. So we basically found the price of the bond here using the ordinary present value concept. Okay, so that's $70.36. So in terms of computing the duration, what we have found now is the one in the numerator here, which is present value of cash flows. So what is remaining now is to multiply it by t, and this heading here you can see is exactly the one in the numerator. So that's what I am going to do next. This multiplies the time period, and this is something I will double click, and this is already adding them. This is the summation of all of these, so you see the total is here. So if you follow the formula now, what we've got is the total for the numerator and also the price, which is 70.36. so this is therefore we just need to divide it by the price, so we got the duration. Remember, this is half yearly because the coupon is paid semi-annual. In order to convert into annual, you simply need to divide it by the coupon payment frequency, which is 2, so that's your duration annual. Okay, now in order to compute the modified duration, you need to make use of this formula here. This is the formula to compute modified duration. Why not I take it on this side so that you can see the formula in the screen. So what I therefore need is the duration is divided by 1 plus the yield, which is 9%. Remember, you take 9%, not 4.5%. Okay, and then divided by the number of coupon payments, which is 2. So this is going to give you the modified duration, which is 10.62. Now, firstly, we found the duration. What does it mean? So duration basically is the weighted average term to maturity, and the reason why you were multiplying it by the time period. This is what you see in the formula in the numerator, t times. So basically, duration is weighted average of the times until the cash flows of a bond are realized. Okay, so you see it this way. You can think it in terms of payback period type of concept. Okay, weighted average term to maturity, that's what duration gives us. The answer is therefore reported in years. Okay, so duration half yearly, duration annual. So 11.10 year is the duration. Now when it comes to modified duration, this concept is more important because this concept talks to us about the bond price volatility, and this is what I'm going to talk next. So what I want you to do now is see the example here wherein I have the exactly similar case like the one I discussed here. So do not worry about other numbers here, just focus on this 25 years bond, and you will see that this has a coupon of 6%. The yield is 9% here, so I just need to find out the price of the bond. So price of the bond we already computed, which is 70.36. So that's what I need to compute, but we already learned on this in my previous video. So basically what I can do is just drag this down so that I get the price of the bond. Well, when I dragged it down, I got 70.36, but this is what I did in order to obtain that 70.36. Okay, so that's how we can obtain it. So that's simple, and we also discussed this in my previous video, so I don't want to talk more on the computation of the price of the bond. But what I want to talk now is the duration that we computed. I want to find this duration that we computed, but this time using Microsoft Excel. And if you need to do that, you simply ask computer, and what you can do is type in equal duration open bracket. Remember here you need to have settlement maturity coupon yield. So we're talking about this particular bond here, which settles on this date, which in fact is now, and then the maturity after 25 years, this will be it. And then you need the coupon, that's 6%. It is talking to you about the rate of coupon. Okay, and then the yield for this particular bond, we're talking about 9% yield, and then we've got the frequency, which is 2, and then the basis, you don't need to worry, just leave it, and you get 11.0953. And if you see here, with all the calculation, you obtained exactly that number, 11.0953, which is, I'm highlighting it here, 11.0953. So you see, it makes our life so easy when we are able to make use of Microsoft Excel provided tool. Of course, the understanding we developed was important, hence the reason why we engaged in this computation, wherein we applied the formula to compute the modified duration. Now that we computed modified duration, we can also compute, we computed duration, we can also compute modified duration. It is just one symbol m that you need to add at the start. That gives you modified duration, m duration 10.6175. You can check here if this was the case. 10.62 is here, 10.6175. So you now also have computed the modified duration before using the formula, and now here using Microsoft Excel m duration function. So what we want to do now is see the application of modified duration. Firstly, in order to understand that, what is important is to find out the percentage price change as a result of change in the yields. Okay, so let's do that. Here, what I will do, the percentage price change is, in the case of this, would be 0 if I just do it for the same number which I want to see as 0, and that's coming correct. But this is something I'll be locking now, so that when I move it for my other yields, for example from 9 to 8.99, then I want it to take 70.43. okay, so you will see that will happen here because we've locked. So now it is the difference between 70.43 and 70.36. So that's how we can find out the percentage price change in bonds, okay, as a result of change in yields. So this is, in fact, the actual data of percentage price change. Now, what we want to achieve is, can this modified duration help us achieve the percentage price change? This is what we want to do. And we've got this formula, which is, as you can see here, D mod is basically modified duration. So this formula is telling you that percentage price change, can you see delta P divided by P basically gives you the percentage price change when you multiply by 100. Percentage price change is basically a function of negative modified duration times the change in yield. So this then basically is saying to you that with the help of modified duration, you can find out the volatility in the price of bond. Okay, so let's see if that is correct. So now, in order to demonstrate that, what I would need is, I would need to make use of this modified duration that we have found. Okay, so firstly what I will do, I will make use of the formula, which is minus this modified duration times, now I need to find out this delta I, which is the change in yield. So in this instant, I will keep the change in yield as 9% against the same 9%. But remember, I'm going to lock it so that when I move to other cells, it will work. At the same time, what I will also lock is this modified duration, so that 10.6175 has also been locked. So now I'm going to take it up and also take it down. Okay, so now I can compare the percentage price change given to me by modified duration and the actual percentage price change. So you can see here that when the yield change is small, such as these, okay, so I'm going to, you can see that the percentage price change given by modified duration and percentage price change, the actual, are here. Okay, but when the yield change is small, the percentage price change is identified correctly by modified duration. But when the yield change is large, when I'm talking yield change, I'm referring to these yields here. As you may already know, these yields here 6, 7, 8, 9, and so on. So the point I'm making is when the yield change from 9% to a smaller values, such as from 9 to 9.01, the percentage change given by the actual bond price change and the percentage bond price change given by modified duration are exactly same. Okay, very small change here, 0.01%, but that's not massive. So it worked for all these yield changes. So between 9 and 8.9 and between 9 and 9.10, the percentage price change is working perfectly. But it doesn't work when the yield change is larger. So let's say when the yield change is 200 basis points, so from 9% to 7% will be 2% point change, which is representing 200 basis point. In that case, the price, the difference here, this column is difference, isn't it? So the difference here is much more larger. So the modified duration has not been helpful. And this is the point I'm making in this diagram as well. Given the relationship between the price of the bond and the yield is not linear, not this line, the purple one, it is not linear, rather it is convex. Hence the reason why when the yield change is larger, the modified duration measure is not effective enough. So the solution in such a case is to combine both the modified duration and convexity. So this then basically means you should also be aware how convexity can be computed. So I have here shown you the formula for convexity. That's the one, but don't worry, I'm just going to apply it and you will see that we can very quickly compute convexity. So without losing more time, let's now compute. Here 1 plus y is what we can see. So 1 plus y is our yield, that's it here. And then what we need after that is power t power. What we need after that is t plus 2. So that's 1, which is t plus 2. So that's what we need to do and we can achieve it. Remember, we need to lock this d4 because if we don't lock, then it cannot be carried forward. So that's the only thing remaining in the case of this part of the formula. So just double click now, then you get all these values. Next thing you need as required by this formula, you can see here t plus 1, t plus 1, and cash flow is multiplying it. That's something I need. So hence the reason why I now have t, which is this time period, multiplied by again t plus 1. The second thing I need to do is this will be multiplied by the cash flows, which is here, and that's what I have done. So I've computed this part as well. So what I can do now is double click so that this is completed for these two columns. So the last part here is requiring me to divide this column by the output of this column here. Okay, so sorry, this output will be divided by this. So that's what I'm going to do. This is being divided by this part here, so I get these numbers. So computed that for all the cash flows, this is being achieved. And the next thing that I need to do is add them all together. So that's sum, and after I have added them together, what I need to do is divide it by the price of the bond. As you can see, P is underneath here in the formula. So this is therefore divided by price, which we know is 70.36. So you can take 70.36. I have divided it. So I'm getting 731.64. So this is my annualized convexity. In order to convert it, so this is my semi-annual half-yearly convexity. In order to convert it into annualized, slightly different than the duration, what you need to do is you need to divide it by the square of the coupon payment frequency. So the coupon payment frequency is 2, so square it. Okay, so that's what we have done. Remember, that's coupon payment frequency 2. Instead of dividing by 2, in the case of convexity, you divide it by the square of that coupon payment frequency. Therefore, we achieve this. So now this is annualized convexity. Okay, so convexity has been found half yearly. This was half yearly. I can say half yearly, or simply write half yearly. Oh, I think I mentioned half, so sorry about that, but it's corrected now, and that's annualized convexity. Both have been computed, so you can see them there. What we now need to do is we now need to find out percentage price change. For modified duration, this was the formula. Okay, and that's what we applied here. Minus modified duration times the yield change. That's the formula we used to find the percentage change in the bond. But in case of the convexity measure, what we need to do is, let me write here, percentage change in price due to percentage change price using convexity will be half. What you need to do is half of convexity measure times delta I square, which is basically yield square. Okay, so this is what you need to do. So let us do that. Half of convexity measure times yield square. So you know the convexity measure that you found is in this worksheet, and we found this number 182.91097. So that's what we found. What we will do next is we'll divide it by 2, and that way it will be half, and then we'll also multiply it by the yield square. So now let's take the case of the yield change, a large yield change such as 7%. So we're not talking about from 9 to 8.99 or 8.90. We're talking about large change in interest in the rate, in the yield, such as 7%. So that then basically means 9 minus 7 will give us, let me do this slowly here, 9 minus 7, we need to be writing 7 minus 9, isn't it? The yield has decreased. So that's what you can do, and you need to square it. Okay, so that gives the convexity given change in the price of the bond. So that's you found is 3.66%. So what we need to do now is we found this as 3.66. I'm going to keep it here, this 3.66 aspect. I will put it in fact exactly here, because this is related to this 7%, and percentage change in, let me take it this side, given by modified duration. I'll just type in MD, and here is the percentage change in price given by convexity. Okay, now what you can do is, this is given by convexity, okay, and this is the one given by the modified duration. So if you add them together, okay, this 21 point this and this 3.66, then you will get it very close to the actual price change, okay, percentage. But remember, something that I computed here, I should have computed it as minus, because it's not B11, yeah, it's B11 minus B16 is what I have done, whereas B16 is this 10.6175, no, that's B16. So what is B16 is the yield, which is 9%. So what I should have done is actually, give me a second here. So let's see this, what is happening. This is given by the convexity, which we found. Remember, we found the convexity given percentage price change, and now the last thing to do is to add this with the percentage price change given by modified duration. So this one here, which is in yellow highlighted, and this one here again yellow highlighted, you add them together, see what is this number, and compare it with the actual percentage price change. I mean, there is still some difference, but this is what you can achieve using the combined convexity and modified duration measure. Okay, so let's do it once again. When it is let's say a change, but on the higher side. So from 9% the yield changed and grew to 11%. What is the percentage price change given by modified duration? It is negative 21.23%. What will be given by the convexity? So what we need to do in order to find that, we knew that the convexity given is 3.66. What we now need to do is equal the convexity given and the modified duration given. We just need to add up. So that brings us to something negative 17.58. Let's compare it with the actual, which is negative 18. So that's again a very close approximate percentage price change, which is possible through combining convexity and modified duration. It was not possible just from modified duration, because modified duration was saying negative 21%, whereas the actual is minus 18%. So we're now much more closer from this 18%. This is negative 17%. And if you see the concept here, this is illustrating the same idea, which is when the yield change is small, then the convexity is not the big issue, hence modified duration given percentage price change will work. But when the yield change is large, such as here or here, you see, because the yield change and bond price relationship is not linear, rather convex, the modified duration doesn't work. Therefore, we need to make use of convexity, and in order to find out the percentage price change, we need to combine both convexity and modified duration together. So it has been a rather long discussion in this video compared to what I wanted to explain, but we have achieved a number of things, including duration, modified duration, convexity calculation, and also the concepts related to them. I hope you will find you found the video useful. So thank you very much for your time, and thank you very much for listening.